Hello everyone. Now let's talk about building survey. As we were talking earlier, building survey is very important and you must do before you start your calculation. Without building survey, calculation is not going to start because you don't have the data without any building survey. In building survey, as we have discussed, we are going to collect basic information about the project, building envelope, construction materials and other internal load, external loads. We're going to talk about climatic data and special characteristics of your project. So this is a sample data sheet. We need to fill it out for each and every rooms if possible. If not, at least for the whole project, we are going to get one uh, building survey data sheet. It's very easy. You're going to fill out all this information that has been given or presented here. In this particular class, we are going to take a sample project, and in the sample project, we are going to discuss all the data that need to be collected, and we're going to put in here. So all the data relevant to location and temperature data, the building envelope data, internal gain and special characteristics, all these things we are going to find out in this particular lecture segment. Okay, here is our building. This is a 3-storied building. Level 1 is in here. Let's bring a pen. Level 1, level 2, level 3. Okay, now before doing load calculation, in the phase of building survey, you must collect all the floor layouts of your project. For instance, uh, we are doing the load calculation for this whole building. In that scenario, you need to collect schematic diagram and floor layout like this one. Remember, if you are doing load calculation for level 2, let's say this particular room, you need to consider data and floor layout for the floor below. This is level 1, and floor up. This is level 3. And if you are doing load calculation for roof to top floor, you have to get the data layout for the level 2, the immediate next floor downwards, and you also need to get the data of the rooftop and its arrangement. So getting these layouts are extremely important along with all the measurements. For instance, for now in this project, we're going to do load calculation for this particular room T1. Then this is a brick made structure. Outside we have this brick wall, and inside we have brick partition like this, and we have a window 5 feet wide, and we also have a viewing panel here. Whenever something glazing or glass is put on the exterior wall, we say it window, and if it is put in between internal walls, in the internal walls, we are going to say it view panel. And when it comes to wall, whenever we say wall means only the partition adjacent to periphery or externals outside. This is your wall. But this is not wall. We are going to say this is a partition. We have wooden window, wooden door, let's say 7 feet by 3 feet, standard one. Here we have some rooms which are hatched. This means these are air conditioned room. So you must also know which rooms are going to be air conditioned and which room are not to be air conditioned. Then building name, let's say building name is XYJ. Location, let's say Dhaka. I'm going to put my homeland. Orientation, let's say south face building. Let's say this is your south. Usage, let's say let's say it's an industrial building. I'm bringing the example of industrial building because if I discuss on industrial building, I can cover all the topics. And if you can do for industrial building, you can do for commercial building, hospitals, also education like schools and residential buildings, everything. So industrial building, if I discuss, it's a wide area, wide topic, gives me allows me more chance to describe all the topic. That's why I have chosen industrial building. Construction type, masonry construction. So I write masonry construction. Okay. So basic information we have now. Now let's move on to this data relevant to weather location. Let me change the color of pen. Weather. We are going to collect the weather data. So now we need to know dry bulb temperature, wet bulb temperature, relative humidity, and moisture in grain per pound for ambient and indoor or target design temperature location. And we are also going to find out the difference in here. So this is very important. And now to do so, we need to use a psychometric chart. First, we need to get the data for ambient location, ambient wet bulb and dry bulb temperature, and indoor target dry bulb temperature and relative humidity. Then we'll move to our psychometric chart and find out rest of the data. And finally, we'll find out the difference here. So let's say ambient condition. To find out ambient condition, we are going to use ASHES database. So this one, if you go to this particular website, let me give you the URL first. The URL is ashray-meteo.info/v 2.0/. So now let me make it a full screen for you. Okay, here's your ASHRAE meteorological data. You can get data of year 2009, 13, 17, and 21. Basically, it is going to provide you data for all the airports, international airport. If your location have an international airport, you're going to get exactly the data of your location. If you do not have, then you have to use data from nearby places. So for instance, you can choose between SI and IP unit. For now, I'm going to switch into IP unit. If you want, you can use SI unit. Now let's zoom in. Here is my beautiful motherland. Now, how to zoom in? It's very simple. The scroll, you can zoom. Scroll out, you can zoom out. Now to find out the perfect location, here is Dhaka. Yeah, I'm going to do right click now. Okay, as I did right click, this particular website or database is providing me nearest weather station database. So for instance, the very close one is A. Goes for Dhaka Hazrat Shahjalal International Airport. The second closest data is B. It goes for Agartala, India. Third closest one, Chittagong here. So A, B, C, D. The E is in here. F, G, H, I, like this. So basically, you're going to use the closest one here. We have the Dhaka city. So now we are going to click in here to get the data relevant to Dhaka city. Now we are just clicked it. Now you have to scroll down. Here they have all the data. We are going to focus data relevant to load calculation for now. So for instance, annual cooling and dehumidification enthalpy design condition, this one is our target. And for now, we are going to get data for 0.4%. We have dry bulb temperature 97 and mean coincident wind bulb temperature 78.8. So let's get this data, 97 and 78.8. Let me 97 and 78.8. Let's go back to our lecture note. What we have is, for ambient, dry bulb temperature 97, wet bulb temperature 78.8. Okay. For indoor space means target design temperature. Let's say customer is looking for 70 degree Fahrenheit dry bulb temperature, and usually customer provides you relative humidity. Let's say target relative humidity is 60%. What we see, we have some missing data. For ambient condition, we need to find out the relative humidity, also the moisture. And for indoor, we need to find out our target design temperature. We need to find out wet bulb temperature, also the moisture. We can do it manually as well as using software. So let's first do manually. Here we have the psychometric chart. Okay. Dry bulb temperature is 90 degree Fahrenheit and wet bulb temperature is 78.8. 97, I'm sorry, 97 is dry bulb temperature. So 97, need to find out in here. 95, 6, 7. Now we need to move on vertically upward. You can use software, but I insist in learning phase, please try to do it manually. Try to do it as many times as possible so that you are very familiar with psychometric chart. Psychometric chart actually very important for the whole journey actually. Okay. And the wet bulb temperature is 78.8. So we have 75, 6, 7, 8. 78.8 is in here. Okay. Let's make a circle in here because we have found out our point of interest. Manually find out. Okay. So we need to find out relative humidity. The relative humidity would be in between 40 and 50. So if you can follow this line, it is in between 40% to 50%. So let's take relative humidity 45%, and moisture is around 120 grain per pound or 119 grain per pound likewise. So let's put it down in here, 45%. And 119 grain per pound. We'll check it back using software to make sure that we are going to get the right data. Okay, for indoor it's 70 degree Fahrenheit and 60%. 70 degree Fahrenheit. So we have 70 degree Fahrenheit in here. It's vertical. Let's put a vertical line. 70 degree Fahrenheit. And 60% is the relative humidity. So relative humidity 60% is in here. Here is our point of interest. Let's remove all other lines. Okay, moisture. The amount of moisture we're going to have is While doing manually, you might make some mistake, but don't worry. Try to do it manually first. This is the amount of moisture in grain per pound, 65. And we need to find out wet bulb temperature too. It's a missing data on the table. So wet bulb temperature is around 60 degrees Fahrenheit. So 60 and 65. Let's put it in the table. Wet bulb temperature 60 and moisture difference 65 grain per pound. Okay, let's check it back using software. We're going to use Ashes database, the same one we have used earlier. Let me make it full screen, will be easier for you to catch. Okay, now in the same website that we have used earlier, we have this particular calculator. Now let's use this calculator, very easy. We need to put this temperature dry bulb. So for instance, for room condition, we choose 70, and relative humidity we went for 60. Now this calculator is going to give me the wet bulb and dew point and all other data. So wet bulb is 61. Remember, we found 60. Now it is 61 in here. And moisture is 65.67 grain per pound. We got 65 grain per pound exactly. So we are in the right course. Okay, well, when it comes to the ambient condition, the dry bulb temperature is 95, I guess. Let me check it in here. Yeah, 97 actually. So 97. And we have wet bulb temperature. How is it? 78.8. Let's put 78.8 in here. So relative humidity 45%. We actually got 45.2 in calculator. So it's okay. Same thing, 45.2. And wet bulb 78.8. We just put it in here. Okay, dew point is 72.3. Yeah, so moisture is 119.6. We exactly got 119, and here is the real value 119.6. So we are actually doing very well. So let's move on. We have the right data to move on. Okay, let me take you back. Now we need to find out difference of all this data. So for dry bulb temperature, we are going to use dry bulb temperature to find out do calculation of sensible load. So basically 97 minus 70, we have 27. Remember, this one is very important. Wet bulb temperature difference is not required. Relative humidity difference is not required for calculation. That's why I'm not bringing it. 109 minus 65, we got 54 grain per pound. This is what we are going to use for latent load calculation, and this is what we are going to use for sensible load calculation. Okay, we are doing well. Let's move forward. Okay. Now remember, for the building envelope, we need to find out U value of each and every construction material. To do so, like in the early class, the class before this one, we have learned how to find out R value and U values. For instance, we have brick wall. So the U value for brick wall is 0.37. We need to calculate it and put it in here. In the early class, in the fundamental, we have learned how to do the calculation of U value. Check it back. For 4-inch partition wall is for 0.48. The unit is BTU per hour per degree Fahrenheit per square feet. It is in IP unit. So for marble floor, 7-inch marble floor, we got 0.52. For 6-inch roof, we got 0.69. And for window, we have 1.24 U value, and for door, we have 0.34. So we need to find out U value of each and every construction material. And if there is some extra attention required, for instance, for internal load, how many people are inside, what they are doing, if they are doing light work or any heavy work. For lighting load, for to put the lights on, you need to put some load, right? For lighting is 200 watt. Machine, let's say there is 2 horsepower motor inside. Hot surface, let's say there is a 5 square feet hot surface. Let's say inside an industrial project there is a machine, and surface of the machine is very hot. We need to find out the area as well as the temperature of the hot surface. It is only required for industrial project. For other project, you can skip it. If hot water pipeline is going through your project, you need to find out the size, the length, as well as temperature. So let's say it is like 150 degree Fahrenheit. Let me do it again. 150 degree Fahrenheit. For hot surface, you also need to know the temperature. Let's say it's 90 degree Fahrenheit, the hot surface. Okay, that's all. Now we have all the data to move forward to do a load calculation. We are all set. So by now we know how to do building survey. So congratulations. Everything seems very easy by now. Actually, it is very easy. Load calculation is not very difficult. You just have to put some attention and some time only. That's it. Okay, let's move forward with the next segment.